Here is the complete molecular mechanism at the replication fork. So you have your DNA gyrase that is rewinding the DNA after the helicase has unwound the DNA, right? So helicase unwinds the DNA. DNA gyrase fixes the supercoiling issue ahead of it, and then the single-stranded binding protein allows the stabilization of the single-stranded DNA. Now that we have the single-stranded DNA, the DNA polymerase can use the single-stranded DNA as a template. So it has a sliding clamp. And again, there's a lot of ATP going in and out. In the leading strand, you can just add nucleotides to the growing strand. However, in the lagging strand, what you end up with is a little bubble of DNA that is repeatedly created these Okazaki fragments through DNA that the DNA polymerase can then replicate. There's a nice little movie here that I highly encourage you to watch because it really illustrates how this process works. The two important terms that you need to understand here are the idea of polymerization. Why is it called DNA polymerase? It's because it's polymerizing the nucleotides. That is, it's adding on nucleotides onto a growing strand. That's the process of polymerization. Another term you need to know is proofreading. So as the polymerase moves forward, it includes its own proofreading, making sure that it's added the right nucleotides to the growing strand. And so this proofreading checks for any mismatches and corrects it as it moves forward. And this is very important if you want to preserve the information that from the parental